Welcome, ladies and gentlemen, to another edition of Code Wars and Qatar in Binary Live. And if you're new to the channel, this is a channel that teaches new developers how to code by solving algorithmic problems, so that you can see how we come to life with the solution. Today we will be solving a 7Q kata called integer difference. So let's try to understand the problem. So write a function that accepts two arguments, an array and an integer. Is an array and this is an integer. Determine the number of times where two numbers in the array have a difference of the integer n. So I'll give you an example like this. This is a set of integers here, and the number given is 4. So we are expected to return 3, and this is a comment section that follows, because there are 3 tuples, or let's say 3 groups, or let's say 3 pairs of numbers that the difference gives 4. This is 1 here. 1 gives 1 and 5. The difference between them is 4. That's it. This is another 1 here. So 1 and this 5 here. The difference is 4. So that's already 2 groups. And then we have 5 and 9. So this 5 and this 9. Now let's understand this second example here. This is an array and the number given is 2. So if we consider this first one here, how many numbers here? How many numbers here gives a difference of 2 with the initial one? There are 2 of them, this 3 and this 3. So that's why we have 1 3 1 3. So if we take the second one here, the second one, this other 3 2 gives a difference of 2. So that's why we have 1 3 1 3 also. So the difference is 4. So if you understand the logic of this algorithm, we take a number, we store somewhere, and then we loop the rest of the numbers to see which of the numbers with gives a difference of n. Which of the numbers gives a difference of n with that number that we stored. That's it. Meaning we'll be looping the algorithm like this from start to end for the first round, and then the second round from the second index to the end, and then from 5, just like that, progressively till we arrive the end. That's the manner in which we're going to loop like this. And then 27. So we won't end at 27 because there's no comparison with another one. So we're going to end at 16 and 27. That's the last looping we can do. So basically there is a for loop that starts at the index 0, and that number should be less than the length of the array minus 1. There's no need to end at the last number. We're going to end at the last bit 1 because it gives us the reason to compare the last 2 numbers. That's it. That's why I ended at array that length minus 1, and we're going to go incrementally. So that's it. So we'll be looping like that for every number. What shall we do? I said we're going to store the first one, store the first number here, and then we loop through the rest to see if there's a difference of n. Once we're done with the first number, we store the second, and then we loop through the rest to see if there's a difference of n. So what do? Let me just create a variable store. This is just breaking it down simple. We're not obliged to do that, and I'm going to put I there. I store I. Now I'll do a second loop. J is gonna start at I plus 1. So let's consider that I was 5. This 5 here. J is gonna start here to do the comparisons. So J is gonna start at I plus 1, and J can go right to the end. So we say array.length and j also goes incrementally. Once we've done that, what do? We now compare. As j is looping and going progressively ahead, we're going to be comparing the difference with the store. On the store. All right, so remember, those are indices, those are not numbers. So at the store, let me just actually store the number, and the number actually is r of I. That's the actual number. All right, so what do? I am going to check if I take the number at position j, if I take the number at position j, and I subtract it with the number that we just stored, is it equal to, sorry about that, I'm going to check if the difference between them is equal to n. Now for the examples that I've given, they always equal positive numbers, but I'm just going to take the absolute value so that even if they reverse the order, it still works. So math.abs, this is the function that gives the absolute value. So if the absolute value of that subtraction of that difference is equal to n, what do? We can start counting the occurrence. So in the beginning, I should probably just have a variable called answer that will be storing the occurrence, or let me just call it count, and that starts at 0. So when we detect this difference here, we increment the count. At the end of all these for loops, we can just return the count. That's it. And let's test the code. We have an error somewhere at the I for loop. Now this is not a comma here, this is a semicolon. All right, let's run the code again, and everything works. All right, so we can get rid of this line 5 here because it was just storing so that it makes more sense, but we can just replace whatever was here inside here. It used to work. So I hope this has been very useful, and let's submit so that we can see if there are other solutions. So that we can learn from other approaches. This is practically what we did, the same thing, just without the store expression I was talking about. What is this? Let the output be this. I don't know, this kind of look a little bit complicated at first glance. I'll just keep that, it's not beginner friendly. This is exactly what we did here. This looks like this. Right, this is exactly what we did, but instead of the normal for loop, you're using for each. So you see this is a for each, and inside there's another for each, so it's the inner loop. It's the same thing, and then you use the absolute values to do the comparisons. So this is practically the same thing written in a little bit more compact format. So why is this one quite long like that? This one is so long, there must be some extra computation not needed here. All right, I think he actually pushed the different combinations so that he can collect the length, something like that. This is what we did. So this is actually this is what we did actually. just that the absolute value he stored is somewhere the difference, so that he can now compare the difference with n. All right, and I don't think he needed, oh well, he had to compare if I is different from j. That's because here on the outer loop he did not stop at the last but one value, and also at j here he never started at I plus 1, he started at I, so that's why he actually needs this difference here. All right guys, I'm going to stop here and see you on another video for another solving challenge. Have a nice day.